Hey everyone, this is David here, David K. Piano, and we also have Farzad joining us. And
Hey, hey.
yeah, so hold on, let me actually um, share this out because I completely forgot to do that. But yeah, so what we're going to be talking about today is useState versus useReducer. So if you have any questions, you want to join us in the chat, uh, just say whatever you want. So first, I'm just going to say, uh, doing a rant with Farzad. um,
I have no idea what David is doing. So leave him
well,
alone.
yeah. Hold on, I'm just sending a tweet out.
Hey, Martin. Okay, we got Martin in the crowd, so he can correct us if we're wrong. I feel confident.
Yeah. Actually, Farzad, while I'm typing this, do you want to give your initial thoughts? Where do you stand on useState versus useReducer? What do you usually use? Um,
Sure, yeah. So I'm gonna be in the category of wrong people to ask this question because I do use machine all the time. So I don't really find enough opportunities to use user state versus use reducer. I don't have the time to debate on that. But usually my use cases end up with being more like user state. But it's quite clear when you have to step out of a bunch of primitive states. When you enter the era of objects as states, then you kind of need to use reducer instead of use state. I feel like when I started with React hooks, I think it was 2018, right, when they came out initially. There was a huge also argument over use reducer versus use state at the time, and many people in the community lean towards the user state because it was more convenient, it's easier to use, but honestly it gets really really messy in scale, because by doing user state we're kind of thinking that the states that we're creating are separate. They don't have the same life cycle. They update at different times, so they don't share the same thing. They're not from the same type of state. That's why you have to manually wire the updates and syncing together, have a bunch of use effects and stuff to sync them together and kind of like make a poor man object out of them. But I feel like when I have a bunch of a state that need to update at the same time, they belong to the same thing. They kind of belong to the same entity. I use reducer over use state for that.
mhm.
That's my rule of thumb.
Yeah, and I would tend to agree with that. In fact, I would go as far as to say that useState is really for simple state updates. And like Farzad was talking about, as soon as you need to actually do stuff with that state, like that state changes due to logic or different rules like that, use reducer really makes sense. So I posted a tweet a while ago, or actually 2 days ago, saying, here's a fun React tip. And so I said fun in the controversial sense, fun as in let's see how everyone responds to this. Use reducer is a better use state, which sounds more like facts than opinion, and that was just to get people talking about it, and it's easier to adopt than you may think. This was actually my main point of the tweet, where, of course, there's use cases for use state, there's use cases for use reducer, but a lot of people aim for use state just because it's like, oh, I don't want to set up an entire reducer to do everything. I'm just going to use state just because that's what is in all of the tutorials and all of my coworkers' code. And so the tip I gave for making it easier to adopt is to group related values together and just spread them in the reducer. And so this is what that looks like. Let's say you have three sets of seemingly disparate data, but they all actually make sense together. This is part of a to-do. You have a message, you have some tags. Just pretend this is an advanced to-do application. And you have a status where a to-do could be active, complete, maybe deleted, maybe overdue, just whatever you want. So instead of that, I was saying, hey, check this out. You could spread both the data and the partial data inside of here, and all of a sudden you just have a reducer where you could just call update to do. So I'll show that over here. And in update to do, you could pass in that partial data. So you could say, hey, I want to update the message of my to do. And this is better than having 3 separate set messages or set status, set tags, etc. But again, the point of this was to show you how to gradually adopt useReducer, because it's easier to go from a useReducer like this to a useReducer where you're actually handling events and logic. That was my main point. And so obviously there were people in the comments saying, you could use state for all of that and, have the special handler, which is basically doing this. So basically their arguments was, instead of useReducer, you could just swap this for useState, and this thing becomes a handler on the outside. You're basically creating the same thing. So there's, really little difference to that. But I go further here to say, like, what exactly is the point of doing all this? So there's a couple of points that I made. The first one is that you have consistent data. And so what that means is that, let's say that you want your message when you commit it, you want it to always be trimmed. So you could do this wherever the like set message state. If you're using useState, you could do it wherever set message is being called and then just trim it. Or you could do it in one place, which is the reducer. And that's sort of the point. With useReducer, you have a centralized place of doing that kind of logic instead of having to find all of the different parts of your app where you need to do that logic. And so the real reason that I put over here is handling explicit events. So basically, instead of saying we're going to just update the to-do from anywhere, we're saying we're going to call events like update message, update status, complete to-do, just all sorts of different things. And so events actually have a twofold purpose. First of all, it prevents you from directly manipulating data where where it might not make sense. Like that's very dangerous to do. Like let's say you have a limit on the number of to-dos you have, then you have to have a lot of defensive logic everywhere to prevent that from happening. And the second reason is because it gives you a really clear picture of the capabilities, the use cases, and the features of your app. So we could see here, what can a user do? They could update the message, they could update the status. So it gives a bunch of semantic, useful language for just talking about what you could do with your app. And I'll stop there if you have any thoughts, Farzad. I know I ranted for a bit there.
No. I completely agree with all the points. I feel like many people who like to use useState over useReducer just like the convenience of the developer experience. Just it feels like it's more convenient, it's easier, where it's not. If I remember correctly, useState internally uses useReducer, right?
It does, yeah. And so ever since I discovered that, which was like a year ago, the React code base has changed so much that it's sort of hard to see, but it comes down to, and I don't have the exact code with me, but there's this internal update state function. And so what that actually calls is update reducer, and there's something called a basic state reducer. So to illustrate that here, I have, let's make a very simple counter app, actually. So we're going to use state first. So const count, set count. So if you thought that my to-do example in the original tweet was too contrived, this is extremely contrived. But the point of it is I want to make it as simple as possible to understand. So we're going to have useState, and let's just have 0 over here. And then count, and we're just going to set counts over here. So now you should see that this says count 0. Hopefully we could probably make that bigger by just doing, let's set the default font size a little bit bigger. Actually, let's, you know what? Why not? Let's make it big. Okay, so let's count 0. But hello from Farzad and David. Count 0. So we have count and set counts, and let's also make a button, which is also going to be very, very small. So this is going to be increment, and on click, we are just going to set the count to count plus 1. So very, very tiny button, but you could see that the count is actually increasing. So to go back to what Farzad was saying about, isn't useState the same as useReducer? Or sorry, is it using useReducer internally? And the answer is yes. Like if we get rid of this and just have const count, set counts, which is all the same stuff, uh, let's have useReducer. And so a reducer takes a current state, which we don't really need here, and it takes the next value. So I'm just going to put that as n. And so we'll just have that as n. And then we have the initial state over here. There are red squigglies because I am punishing myself and using TypeScript. So you're going to see a bunch of those. But thankfully, Code Sandbox lets you render even though there's TypeScript issues. So we're doing exactly the same thing. And so we have set counts, count plus 1, and we see that our counter still works. So we could even go as far as doing this. So function useState 2, and then this is going to be our initial state, and then we could just return that. So we could return const value set value equals useReducer, and then we're going to just remember ignore the previous value and return the next value with the initial state. And then we return that value and the set value. And so at that point, now we've proven that useState, I'll change this. Actually, I'll uncomment this and call this useState 2, and everything should work the same. I'll even change this to prove it. Oops. I guess I have to reload. Yeah, all right, so here we go. Everything is working exactly the same. And so we have this pretend useState 2, which is really using useReducer under the hood. So
yeah, another point is sometimes when you get into debating in between useState and useReducer, people mention that you can abstract over the setter yourself, right? Customize that so that you said about valid. For example, let's say that you're keeping something in the state using useState, and now you need to validate or trim it yourself, like you said, David. The messages in the to-do had to be trimmed. If you use useState, you need to customize the state setter so that you do that whenever you're calling state. Am I right? Because you don't have internal control over how the mechanics work. You can't hook into that. You have to just do it on the call side. And when you know that the fact that useState uses useReducer internally, it feels like you have a reducer encapsulated. You don't have control over that. Then you're customizing the setter over that. It feels like two levels of abstraction for nothing. It's just a haunting fact.
Yeah. And actually, I'm really glad that you mentioned that because here's a really great example. Let's say that we are only allowed to count between 0 and 10. So we have a max of 10, right? So let's say that we have an increment button over here, set count, count plus 1. We could obviously go above 10, which is a problem. So what will we typically do? We would add some defensive logic to say, you know what? I don't want the count to go above 10. So if count is less than 10, I think this logic's correct. Yeah. Then we could increment it. So let's restart this. Now we could increment it, and now we could no longer increment it past 10. So this looks good. Let's say that this is for, adding items to a cart, like you want to increase the quantity of these items in the shopping cart. This works. Like, we could write end-to-end tests for it. They can't go above 10. It's all good. But let's say Farzad wrote this code, and let's say David comes in, and David is like, hey, why can't we just add an input for people to enter the number of items they want? So input type equals number, and then we could say on change, and oops, I actually need that. So we are going to set count to e.target.value as number. And so let's say I'm proud of myself. So placeholder equals quantity.
You find every chance you can to show off that value as number.
Oh yeah, it's super, super useful. So yeah, let's go ahead and restart this. And in fact, I forgot. Let's make this a controlled component. I don't like controlled components, but we'll do it just for this. So value equals counts. And so we have 0. Okay, so I could increment it, and you could see the text over here is incrementing as well, but I can't go past here. However, let's say that I do 7, 8, 9 here. All of a sudden, my logic is broken. The user could bypass that logic that you have over here. So what do? We look at this and we say, okay, let's copy this over here. So now I think we covered everything, right? You can't go above here. Actually, I accidentally did. So I accidentally changed this value. Actually, wait, yeah, this doesn't make sense. So, oops. See, I made a bug already. So if the value is less than or equal to 10, then I could set it. So let me try this again. Okay, I can't set it at all. I can't set it past 5. In fact, right now this is actually a little bit broken because now I can't really change it at all. And that's why having uncontrolled components really helps. But I could increment it. But the point is that we have 2 different places where we have that logic of having it under 10, which is a little bit of a problem. So what would people who like to use useState do? They would say we could just create a handler. So we could say function change count. So new count, and then we could just say return math.min 10 new count. And that should be good. So, oh wait, why am I returning? I have to set count to math.min. So this ensures that the count does not go above 10. So now we could replace this logic. So we could just say change count e.target.value as number. And we could do the same thing here. So we could say change count.
You didn't remove the complexity, you just abstracted it.
Yeah, you're right. I didn't remove it, I just moved it. So, okay, now we are doing it here. We can't increment there. Everything is working. Like, I typed 33 and it immediately went to 10. Not sure if that's the best, user UX pattern, but, it works. So our logic is working. But we have logic spread out like here, it's just, and if we have more places, then at least we have that handler. But let's say that you have more logic. Now you're going to have even more handlers just floating around over here. So let's fix this a bit. Instead of useStates, we could useReducer, and then we could grab the current state, which again, we don't need, and the next state. And then we are going to say, this is just going to be return math.min, 10 new count. So basically, I'm taking this and I'm moving it up here. So the count, the original value is going to be 0. And sorry, this should be next state. And yeah, so I'm trying to see if this is right. Oh yeah, so this looks right. So now I have to just change this to set count. And we should have the same logic. So if we do this, we can't go past 10. So really, when someone is arguing like, oh yeah, we could just useState and then put it in a function, that's exactly what you're doing in useReducer. Notice that all I did was move that function that we created, that function change count, and I moved it up there. And that's it. So now you have everything neatly within one hook rather than, defined as a bunch of functions all over the place.
Actually, if somebody mentions to me that I was doing exactly the same thing with a custom setter, I would say, yes, you were. It looks like it's the same thing, but it's really not, because your logic was only working because the UI was guarding it. It feels like the logic was enforced from the UI from top to the bottom. Whereas right now here, the logic is guarding itself. So the business logic stays into the right position it needs to be, right? Because now the guarding happens inside this state, whereas in the previous one, the guarding was happening on the UI layer.
Mm-hmm.
So if you had another component that also needed to contribute to this state, then you also had to have, either pass a custom setter to that component, which wouldn't be a stable according to a point here, because now you have to use callback because you need a stable setter because you made it custom.
Oh, that's a
Whereas
good point.
dispatch, as said in the docs of React, is stable, so you can just pass it deep into the component as props.
Right, yeah. So basically, if you had a function counter that took that, whatever we want to call that prop, like on counts, in order to prevent re-renders, yeah, you would
Yeah.
have to do exactly as you said. So yeah, and speaking of like just passing things around, because you have everything in this, the single reducer, it becomes easy to just abstract this out into, something else. So we could say function use counts and initial counts number, and then we could just copy paste that and return count set counts, and all of a sudden we have a very convenient uh, convenient way of doing things. So now if you showed this to your development team and they were either pro useState or pro useReducer, it doesn't matter anymore because you have this nice API of what is the current state and how can I affect the current state. So that's what that set count is. Although I think I might have broken something or TypeScript's mad at me. So
Yeah, while you fix that, I would
fixed.
also say that there's also a small bonus here where if you needed to test this logic, you could just test the pure function of the reducer without the entire world around it. You didn't care if it was a React hook or not. You don't even actually need React testing library or just JS DOM or something just to be able to test that logic. It's just a pure function. It's a reducer. Plus, you can visualize it in the context of time traveling or other stuff.
Oh yeah. So that's great. So basically we have count reducer over here, like Farzad said, and we could just. So that's awesome actually, because whatever your opinion on unit testing is, this is nice and isolated. This has nothing to do with with your components. It knows nothing about React. It's just the logic distilled in this one function right here, and you could easily test that. So yeah, that's really really powerful. And then you could use this in multiple different places, compose logic however you want to, and yeah, that just makes things a lot easier.
Yeah, another point would be if you were to scale this up and factor in effects inside the logic, like how state machines work.
Hmm.
Going from the reducer to a state machine is almost straightforward, but going from user state, actually a bunch of them, a mix of them to a use machine or another state machine is just going to be a lot harder. There is a learning curve there.
Yeah.
You would have to go around, go and read the logic and then see the integrations between different parts and then try to remodel that in a state machine. Whereas here, a reducer is almost as straightforward as simply being converted using CodeGen or something.
Yeah. I completely agree.
In fact, I think at some point we should be able to also visualize reducers into Studio.
Oh yeah, yeah. So that's something. Yeah, sorry to sidetrack into. I mean, this is a stately YouTube channel, but yeah. So
Yeah.
something that we've been thinking about a lot is how do we represent just a normal reducer or an async function as something that you could see in the Visual Studio or the Visual Editor. So. And I definitely think it's possible, especially if you have Redux reducers and things like that. You already have some sort of structure where you have all the events listed anyway. So it does become possible to visualize that. Um,
Yep.
Speaking of events, it might be good to show that being able to set the counts directly, that's nice and all, but it doesn't really mean anything because you really have no way of just identifying what the user can do. We see here count +1 and then e.target.value as number. That doesn't really mean anything to us unless we're a developer who's written this and we know what can happen. But in terms of actually trying to describe in plain English terms what could happen, really what we're saying is over here we could increment the counts, and over here we could set the count. So these are two separate kinds of events. So I'm just going to refactor this a little bit. And so instead of next date, we're going to have an event. And so I'm just going to keep this as a simple if statement. So if event.type is increment, let's add the count over here, then we just return count plus 1. If the event.type is set, then we return and I forgot
You
to
have
add
to,
my logic. Yeah.
yeah, you have to clamp all the places.
Oh yeah. So you know what? Let count. I'm being lazy over here. Number. This is going to be count equals count plus 1, or we could go fancy over here. Some of you might be looking at this and saying, "Oh no, you're doing mutation." This is internal mutation. It never escapes the bound of the function. So even if you're doing functional, pure, immutable programming, this is totally fine. And over here, we could just say count equals events dot value. Then we return math.max count. Wait, it's max. So counts 10. So we want a
Actually,
max.
it's min because you'll always get 10 with lower values.
Ooh, yeah, you're right. Okay. I always get that confused. Thanks. Okay, let's see. What did I do wrong? Identifier counts has already been. Oh yeah, of course.
Next count.
Yes, next count. We'll call this next counts. And then we're going to do mat.min next count. And then it's not liking us. Oh, you know what? Let's just say counts. You get the idea. So we have number, event, we'll type later. Okay, so now we have a simple count reducer where we could have two things happen, inc or set. So let's actually use this. This is now going to be, in the React docs, it calls it dispatch. So I'll just put it as dispatch for now. When we convert this to a machine, this is going to become send. So count, dispatch. And so now over here, instead of dispatching count plus 1, we turn this into something meaningful. So we say type inc. And so now we know that the intent is to increment the number. And so it's now, abstracted from the actual logic that we have in our reducer. So if you want to, for whatever reason, disable incrementing or something, then, you could handle that without changing any of the logic over here. So same thing over here. So we could dispatch type set value. Is it value or counts?
Value.
Yes. Okay, cool. Okay, so let's try this out. I'm going to start at some number like 3. Okay, so increment works. I could also change it. I changed it to 89 and it went to 10. Okay. So everything works well. And now, again, we have plain English terms for what the user could do. You could set it, you could increment it, everything works. Just checking the comments real quick. This is a good one. Throwing a debugger statement or a few console logs in a reducer is also easier than triggering and checking a bunch of event handlers. Yeah, I completely agree. So what's being said by Chomp is basically if you had like these use callback functions in here or just all over the place, I wouldn't even know like where you would put them. You'd really have to stuff them inside this reducer because you can't easily remove those functions from the component. You would have to just, add, breakpoints over there. Whereas in the reducer, you could just add breakpoints in here. And like Farzad was talking about earlier, you could just individually test this. So you don't even need to run the app. You could include this count reducer as part of your test suite. And then you could just debug inside there or run tests on it. So it becomes a lot easier, than trying to hunt down event handlers.
Exactly. He has a point. A centralized logic is better than a spread out logic everywhere. Plus, if you were to guard everything and then spread business logic everywhere in the UI, then the concerns are leaking into each other, and you're probably contributing to the cyclomatic complexity of your entire project. because there's a lot of branching everywhere.
Sorry, I'm just making this bigger because okay. I hope that's big enough. Yeah, just for everyone to see.
Nobody asked for this, David.
I asked for it. I'm looking at the screen and everything at the same time. Dev says, actually, I had a related use case. I want to generate visualization out of RxJS pipelines. That might be to something earlier, but yeah. If you
I
want
think
to
you can
expand
already
it more.
do that. I remember Redux observables at the time did that sort of. Yeah, but yeah, probably you can do that out of just native RxJS. I don't know.
Yeah. All right. But hey, since we're on the stately YouTube and doing a stately stream, let's convert this to XState, right?
Mm-hmm.
And actually, I am going to do this because I'm being lazy. I'm going to use the editor. We're going to have
David,
some
I'm going to
fun
ask you a
here.
question before you start refactoring. Before you refactor to have a better intent by sending events to the reducer, you were setting count, like you were set count when you were to increment the value. You were actually reading the current value and then +1 send that to the reducer to be set, right?
Yes.
Is that dangerous in concurrent mode?
I don't think so. If you're using normal useState and useReducer, it's not going to like do a double trigger or anything like that. Basically, and I sort of talked about this in my use effect talk too. When you are between renders, and so this area over here counts as a between render because it's an event handler, that's sort of a safe zone. That's a zone where you know that concurrent mode or concurrent features are not going to do anything weird. React's not going to do anything weird. It's just going to be, firing whatever you have over here. The danger zone is when you're actually rendering. So during that phase, that's when things get a little bit weird, a little bit unknown. But
So
here's fine.
There will be no case where you were reading this like a previous value of count. Basically, the count value has been set to like from 13 to 14, but you're still reading 13 in your component. So your increment is also going to increment to 14 again. I just want to.
Oh, yeah. So
kind of like a situation where you read the count value, like you have set count that gets some like a callback argument versus reading the value directly.
yeah, so it's not necessarily a concurrent a React's concurrent. I keep trying to say concurrent mode, but it's not that. But it's not a React concern. Actually, it sort of is. But for example, if you have like const handle click, and this is a use callback, and you just you know all right. So if we were using set states and this was like set count +1, and you completely forgot the dependency array, which is very easy to do, then yeah, you're going to get into that problem. And I've run into this so many times where count is a stale value because we aren't updating that callback. And this is one of the weird parts about React that you just have to know about.
So that count will always only update it when you re-rendered to get the latest value.
Yeah. Or actually, if you do have this use callback,
it would
it's
just be
never
the initial
going to.
value. Yeah,
It's just going to be the initial count. And so that's actually why, we have an increment event. And because we move the logic inside of this reducer, and this reducer is always going to know what is the current count and what's the event that came in, it's always going to be up to date. So you don't have to worry about dependency management and things like that. Yeah, chomp. we're
okay,
chomping away at the. Okay, Chomp asked, "Isn't that called batching updates?" And so I think what batching updates is more about is like, let's say you had many of these. It's not React is going to batch these into a single update instead of having a separate update for each one of these. So it's a little bit different, but yeah.
Yeah.
All right.
React has so many quirks that we're running out of names.
Yeah.
Yeah, let's do it.
All right.
Refactoring.
So I have a counter. Forget about states because we don't really have a state thing right now, or at least it's something you don't need to think about yet. But there's two things I want to do. We want to increment and that's looking a little funny. We want to set. And yeah, that's basically the two things we want to do. And so in increment, actually, let's go into context and set some things up. We have count. Not sure how well you could see that, so I'm going to zoom in a little bit. There we go. We have count, and our initial value is going to be 0. So Farzad built this. It's really awesome. You even have a little code view over here that shows what it is. So we have counts. And here, I'll try to zoom back out. Okay, so with increments, let's add an action, and we are going to make it an assign action. Do we have expressions in here, or?
Yeah, you can. We treat them as strings for now.
Oh, okay. Yeah. Okay, so we could just say context.counts +1 for increment. And so you could see we have assigned to counts over here. And we could do this in code too. I just want to, try out this feature. So same thing over here, count, and we're going to, this is going to be context and the event. Yeah. And so it's just going to be the event.value. Okay, cool. So I did all this because I'm lazy and I don't want to write all of it out. I'm going to copy the TypeScript code. And yeah, so let's, I even forgot to add the dependencies. We need xdate, we need xdate react. So I'm going to add both of those in there. Okay, so count machine equals, and so this is our big fancy reducer, and we need to import all of these. Did I do it right? Let's see.
Oh, you don't get automatic inference. You just.
That's silly.
Yeah, it kind of broke on Code Sandbox a few days ago.
Ah, really?
Mm.
I didn't realize that. Oh, well. Anyway, okay, so we have our count machine, which is doing two things. It's incrementing and it's setting. And so this is basically the same reducer, except in object form. At least it was generated for us, so we don't have to worry about it too much. And so now instead of this counts dispatch, I'm just going to call this count, or yeah, I'm going to say const state send equals use machine. And again, I'm missing those automatic imports. So imports use machine from xstate react. And yeah, so let's put that count machine. Oops. Machine in there. So const count equals, we have that in the context. And yeah, instead of dispatch, we have send and initial state offline. Oh, you know what? It was reading from, there's a small bug over there. So we just have to fix that. Don't worry, I know exactly what the bug is. But there is no initial state. So it's just, okay, there we go. It's working, but we definitely forgot something. So
it's a stateless state machine.
Yeah, it's a state machine. So you could be in one of two states, either, let's say, valid and max, right? So let's start at the valid state, and states valid and max. And of course, you can name these states whatever you want. And these actions are going to occur, yeah, I guess in the valid state. So
yeah.
Yeah, let me just move this over here to valid. And so we basically want to say whenever the counts reaches above a certain number, in this case 10, then we're in the max state. So, and again, this is a very, very, very contrived example just to demonstrate a few things. And so on the condition that the context.count is greater or equal to 10, then we're going to target max state.
Actually, we don't need to say greater because it never happens here. Am I right?
Yeah, I just like to be safe.
Or maybe it does, like going from 5 to 25.
Yeah. Yeah.
Ideally, you shouldn't allow that, but yeah.
Oh, did I forget to refresh? Okay.
Great.
Cool. So now I can't go past 10. And so there's another really cool thing. And this really shows like why having things in a state machine is actually pretty cool is because you have a few extra superpowers. So let's say I want to disable the button when I'm not allowed to increment the number. So basically when it's greater than 10. I could either duplicate that logic. Speaking of duplicating logic, I could either duplicate it inside the event handler, or I could say, we have the states. If we can't increment, like if nothing is going to happen when we increment, then disable the button because obviously that event's going to do nothing. And there we go. Just by saying if we can't increment, then stay at 10, then, everything works fine.
For the sake of fun, could you just set that to 5 again?
Yeah, so I can't do it here. And that's why having guards is good. But here, let's set this to 5. And then what?
Now I wanted to say when you're maxed out, you no longer accept the set event.
Right. Yeah.
We should, right?
Yep. Exactly.
Yeah. But that can be left as a homework to the reader or the viewer here.
Yeah.
Yeah.
Oh, I love this comment. So one thing I struggle with is knowing when a reducer suffices and when to use machine. As soon as side effects are needed in events, as soon as state gets involved with multiple substates, etc. So I would say, when you have these, multiple states, that's when you could write this as a reducer. Like there's nothing stopping you from writing a state machine as a reducer. This is just an easier way of doing that, right? Because you could either use the visual editor or you could do it in code right here. But another thing which you brought up is the idea of side effects. And so let's say that whenever we reach like the max state of 10, we want to do some sort of effect. Now, if we were doing this with our counts reducer, then we obviously reducers can't have side effects. They need to be completely pure. And with xstate, of course, it's no different. But we would need to do a thing where we would say use effect, and inside of our use effect, we would say if count equals 10. So again, we're duplicating logic right over here. We're going to alert you have reached max volume or quantity. So you could do that, and then you have to add your dependency array here. So count. And so this is what I talked about in my use effect video, where in use effect, if you are doing these one-off side effects, you have to add defensive logic because you're trying to control that fire hose of possible effects happening into just that one specific moment of time where you actually want that effects to occur. So you need this, defensive logic, and it gets a lot hairier than that. In this case, though, what we're doing is we only want to show that alert when we enter the max state. And so the max state is whenever the count is equal to 10. So we could just say entry, and I'm going to hard code this for now. Alert max count reached. So now if we increment, I probably have to reload. There we go. Oh, you can't see that. It does say max count reached. So you know what? I'm actually going to console.log. It's reached. Okay. I need to reload. Sorry. Here we go. There we go. So now you see max count reached right over there. So yeah, you can handle effects this way. In fact, let's do something for fun while we have a couple more minutes. If you have any ideas, Farzad, then
No, I just wanted to add to the previous point on saying that one other use case that using a use machine make more sense than just using data for the state is when you need to reason about the state of the application. Like here, you only care if you've maxed out or not. But if you were to do it using useEffect, then you also had to know about the max value, which was 10. So you get out of you get out of this condition and state that you have to always know about the data and the numbers and the model. Whereas with a state machine, you only care about the state you're in. So you always reason based on a finite state.
Mm-hmm.
I don't know if it makes sense, but it's one of the biggest pointers that I have, in favor of state machines over useReducers or useState.
Right, right. Yeah. I feel like we did this example before. But basically I just wrote a very simple invoked callback, which it sounds really scary, but this is literally 6 lines of code. All we're doing is we're setting a timeout, which is going to send back an event to the reducer. And this is something that you can't do with normal reducers. I said reducer, I meant machine. But again, something you can't do with normal reducers. And we also have a cleanup function. So this is going to feel very much like a use effect that we're embedding inside of our reducer. And so the functionality that this is adding is it's going to actually automatically increment it. And it's only doing it once. Not sure why. Oh, I put set timeout. I meant set interval. Sorry. Your
Honest
interval.
mistake.
Yep. Okay, so now it's going to just keep incrementing until it reaches 10. And then it's going to disable the increment, and this interval is going to be cleaned up. We have this max count reached, like we talked about before. And so now we're showing 2 effects that could happen here.
So now adding more how to say contrived logic into the state machine is going to be a lot easier than just having a bunch of effects and states in your component. Say you were having I don't say like logical timeouts, like the interval was smart enough to wait for your actions and then after 300 milliseconds continue again, something like that. This is a lot easier with the state machines.
Yeah, because this is a use effect. In fact, this is a very, very awkward use effect, like having an entry like that. This is another use effect. So now all of a sudden you have a use reducer, hopefully, and 2 use effects in your component. Or if you're using useState, you have a useState hook and an ad hoc event handler and 2 use effects. But now you just have this one use machine, and all of the logic is contained in there. And I'm going to try out Farzad's feature over here, see if it works.
Plus, you can visualize it, and there's an event log generated for you. Actually, for fun, we could also try to, David, integrate useState inspect and see the updates live, something like that.
Oh yeah. Let's try this first. I'm going to copy and paste the code.
You need a name too.
Yeah. So, oh yes, I do need a name. Otherwise, it will yell at me. So I'm just going to call this count machine. And sweet. Okay, so I have all of my stuff in here. We have a condition, which since it's inline, it's not going to show the full condition. But yeah, same thing. So yeah, now we could see everything that's happening. This is really cool, actually. We also see the assignments that are happening. So we see that we're incrementing the counts over here. And oops, getting used to my new mouse. And we're just setting the value over here. And so this is copy and pasted from the code. We also have that inline code shown over here. A weird invoke ID, but that's just because of how we're importing it. But yeah.
Soon to be parsed as well.
Yes, we're going to parse all of it. But yeah, I love this comment over here, behavior first programming, data as a byproduct. Yep, it's super important. Like, one of the biggest points, and this is actually sort of a common theme with the React tips I talk about in Twitter, is that you shouldn't code just to reach some sort of end goal. You should code because code is read by humans, and so your code should be a representation of how your product is going to work. Like, what are all the features? what are all the capabilities, what are the requirements, what are the specifications. And if you're just coding such that, oh, all of the tests pass and there are no bugs, then that's sort of missing the point. I mean, obviously you should do that. You should, code so that your tests pass. But yeah, you should write code in a way that it has some semantic meaning to it. So, showing you could increment, you could set a value, etc. But yeah, so anything else that you want to talk about, Farzad?
No, good point from Martin. When you have a state machine for your centralized logic, you can subscribe to it because it's sort of an observable.
Yeah, it is.
Yeah, you can't do that with custom hooks. Yeah, could be a big win for some people.
Exactly. All right. Well, again, I just want to rant about useState and useReducer. Just in general, like whether you're adopting a state library like Redux, useState, xstate, mobx, whatever else is out there, or you're using the built-in React hooks. The main point I really wanted to make is that useState is really if you're updating simple values and you don't have any special logic associated with those updates. So if you're just, trying to represent a value in a way that React understands, like controlling an input value, that's a classic example. Then yeah, useState would be great for that. But if you're trying to do any complex logic, which usually ends up being the case, then useReducer and libraries such as Redux, xstate, etc., are going to be your friend. And when it comes to effects, then yeah, state machines are a really good way to go.
Yep, and as David, you say all the time, the code you write might look simple right now, but it actually evolves later. Every code gets more complicated, so you better off invest in something like a state machine right now.
Yeah, exactly. And so that's why just in general, whatever you use, keep that logic centralized. Don't let it spread out all over the place because even if your logic gets super complicated, at least it's in one place. And so now you avoid the extra step of hunting for all the places where that logic touches. So,
yep.
All right. Well, this was a great stream. Thanks for everyone in the comments for joining us. This is going to be on YouTube, so if you want to watch it later.
Yep. Have fun, everybody.
All right. See you all.